Hi students, good evening to all of you. Eagerly waiting for you to join the session right now. So today we are going to start off with your Newton's law, right? Now Newton's law as such students, it's a vast topic, isn't it? It has got too many concepts, too many subtopics involved into it, pulley, blocks, inclined plane, constraint relations and whatnot. Right? So definitely this is one topic which I also think cannot be finished in one sprint session. So I have decided to keep it into two sprint sessions. All right. So in today's session, students, try and understand in today's session what we are going to do. By the way, just once again, let me see if the chat thing is working out here. I'll just okay, fine, that would be kind of fixed. So let's get started anyways. All right, so we have less time in hand and we want to make the maximum utilization of this particular time, right? So students, a lot of you guys have written to me in the Telegram that sir, we have certain pain points, and if you can actually look into those things before we discuss about anything else. So that's what we have decided. That's what I have decided. See, one area in Newton's law, students find it kind of really difficult. All right, or let's say it really causes them a little bit of attention when they see springs in Newton's law. Okay, so that's the reason why I have decided that in today's session, what I am going to do, listen to it very carefully. I'm going to take up one question in which I'm going to do it like in a shortcut manner, and other questions are going to be based on springs. All right, I am going to start off with a very basic question on spring and then slowly increase the level of the questions one by one. All right, so let's get started without any delay, guys. Fine. So here, let me just introduce myself to the students, those who are watching me for the first time. Acha, by the way, students, the ones who are appearing for their English examination CBSE, right? Do you have your examination tomorrow? So best of luck to all of you, those who are appearing for your CBSE English paper. Stay cool, calm. Yes, this is one subject you have to score high because it doesn't involve formulas or things like that, but yes, it will matter in your JEE advanced, right? So definitely keep cool, calm, and all the best from me and the entire Unacademy team to all the students who are appearing for tomorrow's paper. All right, so my name is Sumit Kundu. I'm a BTech graduate from IIT Bombay in civil engineering. I had a rank of 2125 and have had 10 years of experience teaching, mentoring, coaching students for various competitive examinations, whether you call it advanced, mains, NEET, state level, and so on. Okay, so it's basically physics is what I teach. The examination is something that I do not bother about. Okay, so concepts should be clear, and definitely lots and lots of students have studied through me. Okay, so guys, now the ones who have missed out, let's say, please go to tinyurl.com/JEE mobile. It's a video library of all the lectures that has actually taken place last year. So if you have missed out on anything, you know what to do. Okay, and guys, do not forget that if you have not yet subscribed, use the code SMLIVE and right away get 10% discount. Okay, so guys, there we have our first question where I'm going to use some trick, or you can call it some shortcut method. All right, but before we do it, okay, by the shortcut method, let us see how or what to do or what has been asked in this question. See, simple thing, we have seen lot of inclined plane problems, right? You must have already gone through in the entire last 2 years or 1 year, whatever is your level of preparation so far, that in inclined plane, if you place a block, what happens generally? The block will slide down the inclined plane. We know this is an idea which is very, very clear to us. There is no problem in that. Okay. Now, what are they saying? That this inclined plane is given a certain acceleration. It is given a certain acceleration such that this block should be at rest on the inclined plane. Right? Now, some of you may be knowing the method of doing this particular question. It is not a very, very tough one, but it can save a lot of time. You will get to know about a technique, all right? You will get to know about a technique which you can use in the mains examination to really score faster, all right? So that is the motivation with which let's begin this particular question. ठीक है? अच्छा, देखो, now this block is definitely, okay, let me just activate the pen. Okay, so what color do we like? Red color. Fine enough. That's my favorite color anyways, the color red. Anyways, so this block is going to move down the inclined plane and with g sine theta. That will be its acceleration if it is at rest, isn't it? Now, definitely that means mg sine theta force is acting in that particular direction. By the way, mg is the force, the weight, okay, which is acting downward. It will have two components. This component will be mg cos theta. Fine enough, pretty clear. Acha. Now, we are trying to do the traditional method, right? Now, in the traditional method, let me say I have an observer out here and he is watching the entire thing. What is he going to observe? He is going to observe a very, very complicated situation. Why? Because he will see the block is moving along the incline, and since now it has got an acceleration A, all right, it is supposed to move in this direction also. So he is going to see, like, you know, two different kinds of motion. I mean, two different directions. That will make the motion really very, very complicated. So what should we do? We should place the observer on the inclined plane itself. Chalo. Now the inclined plane is the place where the observer is there. Now, if the observer is there on the inclined plane, what is he going to observe? He is going to observe that this block is just going down the incline, right? So motion is restricted to one dimension only, all right? But what has the question asked? The question asked is that what should be the value of acceleration? What should be the value of acceleration such that this block is basically at rest? Now the standard method of doing this question is what? You simply do one thing is, now since he is sitting on a inclined plane which is accelerating, that means he should apply a pseudo force because this observer is on an accelerating reference frame. Do you get it or not, guys? Okay. Yes, some of you have given the answer. It is absolutely correct. I'll tell you a shortcut method to do it, but let me just complete the regular method. Okay. So here, what is he going to observe? He is going to, acha, by the way, we came to that particular point. So he is on an accelerating reference frame. So besides mg sine theta and mg cos theta and the normal reaction here, we are also going to have a pseudo force that will be equals to ma. Simple idea. Now this ma will have two components, right, students? Now see, this is alpha. So if I kind of stretch it here, this angle will also be alpha. So ma will have a component ma cos alpha. Okay? By the way, this is not going to be theta. This is not going to be theta. Rather, this is going to be alpha. And this also should be alpha. So this is alpha and this is also alpha. Okay? Now, if the block has to be at rest, what is the logic? The net force in this direction should be equal to 0. That means ma cos theta should be equals to mg sin theta. Simple, problem solved. Even the traditional method is also not very, very complicated. Okay. So here ma cos alpha should be equals to mg sin alpha. M and M will cancel. So A will become equals to g tan alpha. All right. So option D you can see here is the correct answer. Fine, students, learned about it. Now Would you like to know the shortcut method of solving this particular question? A very, very easy method to solve this particular question. Are you interested? Let's go ahead. Okay, without any further delay in time, let's move ahead to the same question, but solve it without writing any equation at all. Fine. How do we do it? Now, see, simple idea is, if it was a flat surface, if it wasn't an inclined surface, if it was a flat surface, then if I keep the block out here, let's say this block has a mass m, if I would have kept here, it would be at rest no matter what. Even if it was given an acceleration, not given an acceleration, it would be at rest, right? Acceleration required, that means if alpha was equal to 0, what would have been the value of acceleration required? 0. I did not give it any acceleration at all so that it has to be at rest. But slowly, if you increase the incline now, okay, you increase the incline now to some value theta, definitely then acceleration will be a non-zero value. You need some acceleration in order to keep it at rest. Now, let me do one thing. Let me take the extreme case. Extreme. What is the extreme case? The extreme case is, let me make this angle to be equal to 90 degrees. Make this angle equal to what? 90 degrees. Then, if you keep the block here, listen to this very carefully. Very interesting method. Okay. If you keep the block here, now, no matter how high you make the value of A, the block is definitely going to fall, right? That means I can say, if my alpha is equal to 90 degree, A will be equal to infinity, right? Simple idea. Now, let's go to the options. In the first option, it is written G divided by tan alpha. Now what are these? These are the values of A, acceleration. Alpha 90 degree. So tan of 90 will be infinity. Anything divided by infinity will be equal to 0. But acceleration should have been what? For 90 degree, acceleration should have been infinity, isn't it? Similarly, if you go here, G cosec alpha. Cosec of 90 degree is equal to what? 1. So this will become equal to how much? G. So this is also not the right answer. Acha, by the way, let me go back. This is not the right answer. This is also not the right answer. G is definitely not the right answer. And if you place tan alpha, tan 90, then this will become equal to infinity. So option D is the correct answer. I hope you got it. And if you have liked this method, understood this method, students, go ahead and press the like button right away. Okay. If you have enjoyed this method, go ahead and press the like button right away. And then we are going to start off with the concepts of springs, because a lot of students have said this to me over the Telegram. So if you people have any problem, definitely remember to download that app and send us messages, because our lectures are prepared in accordance to what is your demand. We don't do it just out of the blue. Okay. So fine guys, let's move ahead. I don't see the like buttons coming up. Guys, come on, come on, come on. If you have not pressed the like as yet, go ahead, press the like button right away. Okay, now let's move on to the next question. Okay, so what do we have in this question, students? I'm going to start off with the springs. I'm going to start off with a very, very basic question and then slowly raise the level of the question. So after today's lecture, I can guarantee one thing, that if there is a question coming on springs, there should not be any trouble at all. I mean, you should be more confident after today's session if you see a spring in your Newton's law question. Okay. Now, what does this question have? What does this question have? That this is a 4 kg block and this is a 6 kg block. Okay. It was in a stretch situation. Okay. It was in a stretch situation. And then when you left it, it started moving with 1.5 meters per second square. And then they have asked us what will be the acceleration of this one. Simple question. Simple question. All right. Let me just go to this place. We just saw that this was 4 kg and this was 6 kg. Simple idea. Okay. So this started moving with what? 1.5 meters per second square. Initially it was like stretched. The spring was stretched. You leave it, it will start accelerating. Why? Because when it was stretched, there was spring force. Spring force acting on these blocks. In which direction? On B, in this direction. On A, in this direction. They called this direction as westwards. So this is going to be eastwards. Simple idea. Okay. I mean, we have north, south, east, west. That's the standard that we are taking. Okay. So what will be your Fs? Fs will be mass of this block, 6 into 1.5. That will also be equal to this. That is 4 into acceleration of A, which implies acceleration of A will be equal to 6 into 1.5 divided by 4. 3, 2. So definitely this will go 1.5 times. 15 into 15, 225, and point out here meters per second square. Simple question, right? In which direction? In the eastward side. Eastward side. 2.25 meters per second square eastward. So option B is the correct answer. The first question, very simple, logical, and easy. Okay. Now, students, let's move ahead to the next question. What do we have in the next question? Now see, slowly the level of the question is going to increase. Slowly the level of the question is going to increase. All right. So if you are paying attention, let's go to the end of the lecture, where after today's session, you will have zero problems with respect to spring block systems. All right. So what do we have in this question? See, now instead of one spring, we have got multiple springs. 1, 2, 3. It has a spring constant of 600, 200, 100. All right. Now they are asking that if I kind of push this towards the right by 20 millimeter, if I push this towards the right by how much? 20 millimeter. What will be the net force in Newton exerted by the 3 springs on the mass? What will be the net force exerted by all the springs? That means how much will be the net force experienced by this particular block if I move it by how much? 20 millimeter. All right. So how do we go about it? Let's discuss this particular problem. So here I have the diagram and we have got enough space to solve today. Okay. Now how do we go about it? Try and understand. These 2 springs, listen to me very carefully. These 2 springs are basically in series. All right. These 2 springs are in series. So I can replace this 2 by a single spring. And the K equivalent of that spring will be 600 into 200, that is K1, K2 divided by K1 plus K2. Remember, it's a formula. If springs in SHM, you must have studied, or let's say if not in SHM, then right away here itself we can look into that particular formula. That is equivalent spring constant of 2 springs if they are in series is given as K1, K2 divided by K1 plus K2. This is just how we consider just the opposite of your resistors. In resistors, if they are in series, we do R1 plus R2, just the opposite of it. Here K1, K2 divided by K1 plus K2. This is what we follow. All right. So how much will be the value out here? Let's have a look at it. This will be 800. So 600 into 200 divided by 800. 0, 0 cancel, 0, 0 cancel, 2 4 times, 2 2 times, 300 comes to 150. All right. So this will have, if I replace both of them by a single spring, it will have a spring constant of 150 Newton per meter. Okay. Now look at this very carefully, students. One thing that you will learn and not forget after today's session, that is springs in series and in parallel and how to use them in Newton's law question. Okay. Now here this spring and this spring, they are in series or in parallel? Come on, put it into your text boxes. Are they in series or are they in parallel? Come on guys, let me know. Are they in series or in parallel? Fine, good, great. Chalo, let's look at it. See, simple thing. How do I decide? If I move this by 20 millimeter, there will be a compression of 20 millimeter here, and there will be a 20 millimeter elongation in this spring, this combination of this spring. Okay, so we can say that these two springs are basically in parallel. All right, and if they are in parallel, then your K net will be equal to 150 plus 100, so that will be 250 Newton per meter. And if you have to find out the force, that will be K net into delta x, whatever will be the displacement of this 10 kg block. Whatever will be the displacement of this 10 kg block. So K net is 250 into 20 millimeter into 10 raised to the power minus 3. Why did I do it? Because it was in millimeter. I converted it into meters. Okay. So if you solve it, you will get 5000 into 10 to the power minus 3. So this will come out to be 5 Newton. So 5 Newton is the net force experienced by that block due to all the springs. Okay. So option B here is the correct answer. Okay, so guys, I hope you've learned this concept that if you have got multiple springs, how to deal with such kind of questions. Okay, now let's move ahead to the next question, dear students. I hope you're enjoying this session, and if you are enjoying this session, do not forget to press the like button. Okay, now students, let's see this question, slightly graded up. Now we are going to see some motion, some acceleration taking place out here. Okay, now what do we have in this question? Very simple question. Okay, but a little conceptual. Okay, if you know the concepts, there is no tension at all, there is no problem at all. Okay, so I'm trying to build up these micro concepts within you. See, I thought initially I'll bring some 5-6 very good bombastic problems, all right, and then I'll show my skills of solving those. But ultimately what happens, some students, they do get demotivated. They like, how do we solve such complicated problems if we don't know the basics or the fundamentals? So I thought in today's session, I am going to clear all your concepts. And after today's session, in this particular lecture, after today's lecture, all your concepts, all the problems which has been there in your mind related to springs is going to evaporate. All right, it's going to evaporate completely once and for all throughout the entire lifetime. Okay guys, ready? Let's go ahead and check this out. What do we have here? I have got a 2 kg block. 2 kg block connected to a spring here, and there is another 2 kg block. On the top, I have got a string. What they are asking us that if this string is cut, then what will be the acceleration of block A and acceleration of block B? Okay, what will be the acceleration of block A and acceleration of block B? How do we get it? Simple idea. We see, when there is motion involved, we need to draw the free body diagram first, and then we will talk about what is going to happen due to these springs. Okay, so guys, definitely here, let me change the color right now. It's becoming a little monotonous color. So there is going to be tension here. There is going to be tension in this string. Everybody is aware of that. Okay, fine. Then there is going to be some gravitational force acting in the downward direction. Okay, students, if you leave this arrangement like this, think about it. If you leave this arrangement like this, there is going to be an elongation in the spring. Because of which, what do we see? That the spring force will be in this direction, right? And on this block, it will be in the upward direction. On the bottom one, it will be in the downward, because it will try to restore its length. So on the top one, it is going to be in the downward. On the bottom one, it is going to be in the upward direction. Clear? So as long as the string is intact, listen to it very carefully. As long as the string is intact, these two blocks are basically at rest. They are at rest. So I can say that F net on the upper block can be written as your T minus Fs minus 2g, right? That is the net force acting on the upper block. All right. F net 2 on the lower block will be Fs minus, now here on the lower block 2g is also going to act in the downward direction, Fs minus 2g, right? Now, simple idea. The lower block is also at rest. Listen to this very carefully. Lower block is also at rest. That means your Fs should be equals to 2g. Fs will be equals to 2g. And if you cut this particular string, then tension will also become equal to 0. Tension will also become equal to 0. That means your F net 1 will be equal to 0 minus Fs, that is 2g, and another minus 2g. So this will become equals to minus 4g. All right, that will be the net force acting on this 2 kg block. So what will be the acceleration of this 2 kg block? The acceleration of block A will be minus 4g divided by the mass, that is 2. So this will be minus 2g. All right. So minus 2 into 10, this will give you minus 20 meters per second square. So this will be the acceleration of block A, right? What about block B? Try and understand. The spring force, listen to this concept very carefully. Just after the string has been cut, the spring force does not change immediately. This you must remember for all the questions where they burn the string, cut the string, and then they ask you what is going to happen just after the string has been cut. Remember, the spring force does not change suddenly. After some time, when it starts falling, definitely it's going to have a greater acceleration. There is going to be compression, all right, because of which its acceleration is going to decrease, because now the spring force will act in the upward direction, and then it will also start accelerating, and then finally both will go down with g, okay, such that both will have the same acceleration, right? But initially, after you have just cut it, the spring force remains constant. Now, if the spring force remains constant, then Fs is already equal to 2g. That means the net force on 2 kg will still be equal to 0, which means that option C here is the correct answer. I hope you understood this particular concept. All right. And if you have liked it, do not forget to press the like button, my dear students. All right. Go ahead and press the like button, and then we can move on to the next question. Okay, so what do we have in the next question? Some more upgradation. Wow, this is superb. Let's have a look at this question here. See, in a pulley, if I put a spring, mind becomes a little complicated. Okay, mind starts to worry that we studied about pulleys, fine, but in a pulley, if I place a spring, students, after today, these kind of figures will not look terrifying for you. Okay, micro concepts, you need to build on that particular thing. All right, so what are they saying? That there is this block M of mass small m, and you are holding it, right? You are holding it with your hand, right? And this 2m, listen to the question very carefully, this 2m block is at rest. Why? Because you're holding this block of mass m, right? Now, if you leave this block, if you move your hand away and you leave this block, then what will be the acceleration of this block? I hope the question is clear. Let me put it here. Say you are holding this block. If you're holding this block, the system will be at rest. So 2m is basically at rest. Fine. If you leave it, then with what acceleration will block A move? Clear? Now, let us look at the solution. Fine. Let's move ahead. Okay. Chalo. See, simple idea. There will be some spring force here. There will be some spring force. I hope it is pretty visible to you even if I use the blue color, right? It is pretty visible to you when I use the blue color. Okay, chalo guys, if you like the question, if you enjoy this particular question, do not press to click on the like button, share and subscribe. Okay, so here I have spring force Fs. Now listen to the question. Okay, we have less time left. There will be some tension here. There will be some tension, right? Now we know that Fs will be equal to this tension because in between there is nothing else. So whatever is the spring force in this spring will be equal to the tension out here, right? Now they are saying that this 2 kg block is at rest. That means the tension should be equals to 2 mg. The tension should be equals to how much? 2 mg. Fine enough. Now when you remove this, this block A will come into motion. But what are the forces acting on it? Remember the concept. When I suddenly leave it, the spring force does not change immediately. Okay, the spring force remains same for some amount of time. So just after I remove the hand, what will be the spring force? It will continue to be tension, which is equal to 2 mg. So 2 mg is going to act in the upward direction. 2 mg is going to act in the upward direction, and in the downward direction, you will have mg, right? So what will be the acceleration of this block? Total force 2 mg minus mg. So mg is the net force acting on a mass of m. So what will be the acceleration of this block A? Will be equal to g in the upward direction. It will be equal to g in the upward direction. Now, I hope you understood it. Click on the like button. Right? Now, let's say we twist the question a little bit. How exactly? Let me make it very clear to you. In the second scenario, what I am going to do is, I am going to hold the block B. I am holding the block B right now. Block A is at rest. I am holding the block B, block A is at rest. And then if I remove my hand, then what will be the acceleration of block B? This is the twist in the second question. First, I was holding block A. I removed the hand and wanted to find out what was the acceleration of block A. Now I was holding block B and I removed my hand. Then what will be the acceleration of block B? So this is what I want to find out. Clear enough? Chalo, let's have a look at it, how to do it. Okay, so tension will be T. This will be spring force. On the block also spring force in this particular direction. Mg will be in the downward direction and 2 mg in this particular direction. Clear enough? Alright. Now they are saying this was at rest. Listen to it very carefully. This was at rest. That means Fs would have been equal to mg and Fs is also equal to tension. And when you remove the hand, what is the net force acting on this 2m? The net force acting on this 2m is 2 mg minus tension, and this can be written as 2 mg minus tension. Tension is Fs, Fs is mg, so you write it as mg. So the force, net force is equal to mg. So what will be the acceleration of B? Will be mg divided by, what is its mass? 2m. So mm will get cancelled. This will be g divided by 2. Okay, simple idea. G divided by 2, option B is the correct answer. And in which direction? In the downward direction. Hope you enjoyed this particular problem, my dear students. Okay, someone said, Sakit Pandey said, I have a problem. Sakit, if you can tell me what is your problem, I will solve it for you. Okay. By the way, guys, till Sakit tells me what is his problem, what we can do is we can go to the next problem because time is less. Only 10 minutes left, right? Only 10 minutes left, and we want to know what exactly sir has in store for us. Now blocks are there, students. Blocks are there, and in between I have got a spring, right? but this time I am making the surface rough. It's not smooth anymore. I'm making the surface rough. So let us understand the concept here. See, if I do this particular problem, then I expect in the next question like this, or let's say this, can be done easily by you guys. Okay, these questions should be done by you students, ekdam like a cakewalk. Okay, there should not be any problem at all. Advanced level question. All right, you will see how easily you will be able to do this question. This will remain as a homework for you, and if there is time, we will solve it in the class itself. Okay, but let us have a look at this question here. What does this question say? The question says that I have got a 2 kg block, a 3 kg block, and in between they're connected by a spring, and the coefficient of friction between this block and the surface is 0.3, and the coefficient of friction between 3 kg block and this surface is 0.4. All right, now what can be the maximum compression or elongation, all right, such that both the blocks remain at rest? I hope the question is clear. What will be X max? X maximum, what should be the value of X maximum such that this block and this block will remain at rest? Students, in tomorrow's session I am going to do constraint relation problems. Okay, constraint relation, one of the another terrifying areas for you. Okay, pulley constraint, block constraint, and take up questions on friction also, because these three areas are like really troubling for you students. Okay, so yes, so that's the reason why I say, if you are not writing to us on Telegram, we will not know what exactly do you want, isn't it? Since students had written to me, I got to understand what is your demand, and based on your demand I am able to design my lectures. So remember this, communicate with us, we will get back to you with whatever you wish for. Okay, chalo guys, let's not waste time now. Let's say this was stretched. Assume this was stretched by a certain amount, let's say X. Clear? If it was stretched, then the spring force will act in this direction, and the spring force on this will act in this direction. Clear? Here friction will be in this direction, and on this the friction will be in this particular direction. Clear enough? Let's take the first scenario where this one will not move. Let's take the first scenario, let me take it as X1, where my 2 kg block will not move. Then what will be the spring force? The spring force will be 100 into X1, and that should be equals to F1 maximum. That is the maximum value of the first friction. Clear? Now this can then be written as 100 into X1 is equal to mu, that is 0.3, and into the normal reaction, that is equal to how much? 2 into 10. Simple idea, which implies 10 cancel kar do. X1 will be equal to 0.06 meters, that will be equal to 6 centimeter. It is an easy question. See, concept based hai bas. ठीक है? The next question, the next part of the question, let's say we'll take the second scenario where 3 kg block does not move. Okay, so spring force, let's say this time you compress it by x2 or stretch it by x2, then the spring force will be K, that is 100 into x2 should be F2 maximum. So that will be 100 into x2 will be equal to simply 0.4 into M, that is 3 into G, 10. 0 and 0 will cancel, x2 will become equal to 0.12 meter or 12 centimeter. So should we take 6 centimeter or 12 centimeter? Students, should we take 12 centimeter or 6 centimeter? Definitely 6 centimeter. Why 6 centimeter? Because if I make it 12, definitely this 2 kg block is going to move. But if I take 6 centimeter, I need to take the lower of this two. Okay, so if I take 6 centimeter, definitely it is not going to move. So the maximum stretching of this spring that I can do is that of 6 centimeter. Did you notice something today, that most of the answers were option B out here? Well, that is also a strategy in JEE mains, but we shall talk about it sometime later. Okay, now here, moving on to the next question, guys. This is one homework question that I leave it for you guys. And if you are watching this video live right now, good enough, you can give the answer right away on the chat box. Okay, but let's say you are watching it later on some other time. Okay, do not forget to write down the answer on the comment section. Okay, also write down, students, how do you find this lecture and what else do you want me to bring to you on the YouTube channel, in our JEE English channel. Okay, it's very important that we stay in constant interaction with each other. Only then we will be able to provide a lot of quality things to you guys, because we'll know exactly what exactly do you want. We know what you want, but we also want to give you what you want. All right, fine. Confusing, let's not bother about it. Do this question by, like, try to do questions wherein you can twist by reading through the questions. See, here it is simple. It is an extension of whatever we did some time back. You are holding C. Okay, what is in this? You're holding A. You're holding A. All right, and this was at rest. This was at rest. You remove your hand. Then what will be the acceleration of block A? In one, just do it when all the masses are 1 kg. All the masses are 1 kg. In the second one, you make this C to be 2 kg and then solve it. And then solve it. Clear? You will see there will be certain variations. And if you are able to solve it with 1 and 2, rest assured, give a pat on your back and tell yourself that any questions on spring, if it is coming in JEE mains, you will be able to do that particular question. I can guarantee you, after today's session, all your concepts must have got cleared right now. Acha, guys, ye question to ho jayega. This is another question that you must attempt. Homework. All right. It's a multiple choice, by the way. Let me tell you. So if you have got more than one answer correct, write it down into the comment section. Okay, we shall see. I'll get back to you with the right answer. Okay, and also maybe a video within a couple of days with the solution of this particular question. Okay, but I want you to attempt it first. Acha, guys, this will be done. By the way, one good news. This was the question which appeared some years back in 2008 when there was IEEE. Okay, this was one question which was on springs. If you read through the question, it's very simple actually. There was this block of mass small m, it was connected with a spring, and there was this another block of capital M. They were lying on a smooth surface and F force was exerted on capital M. They asked us what will be the acceleration of block mass m, small m. Okay, very simple question. All right, after today's session, I'm definitely sure if this question would have come, right, there is no chance that you would have not scored in this question in the JEE mains. All right. Acha, guys, that's it for today. There was this one question I wanted to take up for shortcut, but yes, time did not permit today, but I'll take it up for tomorrow's session. Doesn't matter. So, guys, that's it for today's session. I hope you have enjoyed each and every bit, each and every moment of today's session. So guys, here we have something really interesting, the Instagram page, which will give you a lot of info about what all is happening at our Unacademy JEE official channel. Okay, and yes, students, as I already told you, see, we get to know about your problem areas, your pain areas only if you are able to communicate it to us. Right? So do not forget to download this, clear, and then go on to this particular group and send down all your messages, whatever you have in your heart, just empty it in front of us. We'll get to know about it and get back to you with the relevant solutions. Okay. Acha, guys, if you have not done the subscription so far, remember it's a very testing time for all of you guys. If you have not done the subscription so far, go ahead, search for, like, you already know we have the live classes. You can chat with the educators. We have the interactive polls. We have test series and analysis. See, this is a super important point. This is a super important point right now in the last days of your preparation. Okay, so definitely look into this particular thing. We have live doubt clearing sessions. Click a photograph and just put it out here, and we'll know exactly what your doubts are. All the best educators, more than 60 educators just for JEE mains. So I mean, I am sure, like, you know all of the big names are there in this particular platform, right? So if you have to study from your favorite teacher, yes, you must attend the plus sessions. Just imagine if this is what we can do in 1 hour. If this is what we can do in 1 hour, then what difference the educators can bring to your preparation if you are there on the plus platform. All right, it is very important, okay, that you understand that why are we telling this thing to you in every session, because we want to bring that change in your lives, in your preparation. Let's forget the old traditional method of preparing for this competitive examination. Times are changing, and that's the reason why we are stressing on this point again and again, that how useful or how important this subscription is for you guys. All right, now maybe making things a little easier for you, what I'll do is I'll tell you, if you have not gone through the process, students, in step one, search for Unacademy Learning app. Unacademy Learning app, once you get it, you will definitely get it. Click on the install button, and once you press on the install button, what is going to happen? Your life is going to change. How exactly? Let me tell it to you. See, simple idea, you would choose plus, definitely choose plus, because in plus all the features are there which I was talking to you about. Okay, it's only in plus that you have those live sessions, interactive polls, live doubt clearing sessions, okay, and all that. And then choose IIT JEE, because that's what you're preparing for, right? If you're preparing for IIT JEE, you need to press on that particular thing and not anything else. Do not choose UPSC, anything else, and get subscription. Once you press the get subscription, you are going to be directed to the payment link, and before you pay, code SMLIVE. Put on the code SMLIVE, and right away you will get 10% discount. All right, and that should make you really happy. Clear? Do not forget to use the code SMLIVE, dear students. And let me tell you, if you have come to the channel, if you have watched today's video, and if you are new, do not forget to press the subscribe button. Yes, fine enough, you have pressed the subscribe button, you got subscribed. But some students, they forget to press on the bell icon. Now, what is the importance of the bell icon? If you do not know, that is, whenever we have a session, whenever there is a new content being uploaded into the channel, you will get notified immediately about anything that is happening on the JEE English channel. Okay, so besides subscribing, do not forget to press on the bell icon button. And guys, do not forget the like and share. The more you like and share, the better it is for the growth of the entire nation, because we are teaching here for free. All right, so let everyone know what Unacademy is doing to bring a change in the life of the students in this particular country. All right, by the way, students, good news is whatever I have taught to you today, all of it is available in a PDF format, so you can go ahead and download it. And guys, not just JEE English, we have got other channels also. We have got NEET, JEE, and for foundation. So all these channels are present. So in case you have got a brother or a friend or a neighbor who is interested to prepare, you can always suggest to them that this is what is there for free. go ahead, explore it, learn from it, and then when they think that there is the right time that they would want to explore the Plus platform, they can just use the code SMLIVE and get right away a 10% discount. So students, that's it for today. See you tomorrow again with Newton's Law Part 2. Thank you.